The fundamental counting principle. Okay. If I have m decisions, if I have m decisions can be made, then I have m ways of making it. If I have n decision made, then I have n ways. If I have the decisions of both of them, then I have, what would you think? Mn. M times n ways. Okay, so let's put this into action. The ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you could only choose one flavor and one topping? Okay, so how many cone sizes do I have? 3 times how many? 15 ways I can have it, right? Times, what's the last one? 8 toppings. Put that in your handy dandy calculators. Okay, 3 times 15 times 8, 360 different ways. Okay, example number 2. Virginia license plates. By the way, you guys, some of you might have careers making license plates.
It sounds terrible.
Huh? Yeah, I didn't know. I didn't know if you youngins realized that it would get that joke or not. That's sarcasm.
Oh, I got it right away.
Did you? Cool. All right. So Virginia license plate consists of 3 letters followed by 4 digits. Okay, let's take a look at the first letter. What's the choices of my letter? How many choices do I have for my letter? 26. There's my first letter. What about my second letter? How many choices? And the third letter? 26, right? Okay, now,
I didn't think this would be algebra.
digits. Now, digit is what? 1, 2, 3, 4, 5, 6, right? Single digit. How many choices do I have?
10.
There's my first digit. Here's my second digit. Here's my third digit. And here's my fourth digit. Yeah, since you guys just did that science test, you probably ran into this, right? 26 to the third power times 10 to the fourth power, right? Grab your handy dandy calculators. 26 raised to the third power times 10 to the fourth power. And I get 1, 7, 5, 7, 6, 1, 2, 3, 4. So we got, what, 17 million? Did I miss one?
You have to, no, you have to move the first.
1, 2, 3,
back
4.
behind 5.
1, 2, 3, boom. 175 million. You're right.
No.
Number 3, Nick's science test. Hey, look at that. They even mentioned science test. There's a section with 12 true or false questions. How many choices do I have? How many choices do I have per question? 2, right? True or false?
2 to the power of
2. 2 to the power of 12. 2 times 2 times 2 times 2 times 2 times 2. 2 raised to the 12 is 40, 96.
Look at that. Is that 12 times 2 right there?
Okay, to enter their home, the Clayton family enters a 4-digit code. Yes, sir.
Actually, it's not.
I don't know. Well, it could be 10,000. I don't know. Well, I'll just put it over here on the side and see what it is. Okay, how many codes are possible?
4-digit code is what, 9 or 10? 10 to the power of 4.
10 to the power of 4, which is a 1 and 4 zeros. Hey, look at that.
Oh,
Huh, that's crazy.
It's almost like you.
It's almost like he did the problem in his head. All right, so pretty easy stuff, right? All right, let's talk a little bit about factorials. Now, factorials. We're going to use the representation of n to the exclamation point. And that's the way I make my n's. Get used to it. Don't complain or whine. Just deal with it. Okay, the definition for this is n factorial is the product, we're going to be multiplying, of all the natural numbers from, well, we start at whatever n is, right? And we multiply down from there all the way to 1. In other words, 9 factorial is, well, we start at that n, which is 9, times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1. Which equals, anybody do this in their head? We're going to cheat. We're going to let our calculator do it.
I love cheating.
Okay?
Wait.
So I'm going to put in 9. I'm going to hit the math button. And I'm going to go to probabilities. And the fourth one down is our factorial symbol. Hit enter. 9 factorial is 3, 6, 2, 8, 8, 0. $12 factorial. 12, math button, probability, number 4, enter, enter. See, I got 4, 7, 9, 0, 0, 1, 6, 0, 0. Another 479 million. Hey, that's a teacher salary. 8
In about 1,000.
factorial,
That's like 12 lifespans.
enter, 40, 320. 17 factorial, so 17. Math, probability, number 4, divided by 11, math, probability, number 4, enter. And I get 8, 9, 1, 0, 7, 2, 0, 8 million, 9 million. All right, youngins. How many, what's 0 factorial? Huh? 1. Who said 1? Fantastic. It is 1. Oh, you cheated. You used your calculator. Any questions about factorials? All right, permutations. And we have a symbolization for permutations.
Just staring at me.
I have capital P, and then I have my number of choices or objects available, right? So my N is over here, and then R is the number of objects for arrangement. I'm going to use purple. I like purple. Okay, we have a formula for that. P, number of objects available by the number of arrangements available for them. And that's going to be n factorial divided by n minus r factorial. Now, you're saying sometimes we'll be in situations where the n and r are equal, or you won't even have the choices of arrangements. So it'll be just n and n. Okay. All right. Examples. Number 5. How many ways can you arrange the letters in the word dinosaur? So order. Oh, I forgot to put that up here. Order matters. Yeah. In other words, we can't just. Yeah, go ahead. Okay, so how many ways can you arrange the letters in the word dinosaur? We're going to have our permutation. And what are my choices for letters for the word dinosaur? What's my N? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And how many ways can I order those? 8. Well, I'm only going to be able to order it 8 ways, arrange them 8 ways. So I could use our shortcut formula here. P, when my n and r are the same, or nn, I use n factorial. So my n is 8 here, so this is just 8 factorial, which is, we did this up here somewhere, didn't we? 8 factorial, 40,320. I think my green is running out of ink. All right, number 6, 7 students. So what's my n? That's right, 7. Are competing in a geography B. How many ways can they finish in first, second, and third? What's my R? First, second, and third. What's my R? 3. Okay, so this is going to equal, my N is 7 factorial, right? Over my N, which is 7, minus my R, which is 3 factorial. So this equals 7 factorial divided by 4 factorial, which is handy dandy calculator time. 7 math probability number 4 factorial. Uh-oh, what happened? 7 math probability factorial divided by 4 math probability factorial. Hit enter, 210. So I have 210 different ways to do this. Questions, comments, concerns? Bless you. We good? All right. I've got a few more here. Melanie's taken 4 classes, so what's my N? That's right, 4. American History, Algebra 2, AP English, AP English and Chemistry. How many ways can these 4? So what's my R? That happens to be my N. Okay. So we could use our shortcut formula, n factorial, which is 4 factorial. And you should be able to do this in your head, right? 4 times 3 is 12, times 2 is 24. Number 8, let's see, there are 16 players on the team. So what's my n? That's right, 16. How many ways can the coach make a 9-player batting order? My R is 9. So I get n factorial, 16 factorial, divided by n, 16, minus r, which is 9 factorial. So 16 factorial divided by 7 factorial. Handy dandy calculator time. 16 math probability 4 divided by 7 math probability 4. Enter. It is 4, 1, 5, 1, 3, 4, 7, 2, 0, 0. Wow, that's a lot. 4 billion different ways. Wow. Okay, number 9. There are 28 students in Mr. Miller's homeroom. Yeah, he had 28 students. That's why they all shagged him out, and that's why he retired this year. So my number is 28. How many ways can the students elect a student council representative and alternative? What's my R? 2. Okay, so I have my n factorial, 28 factorial, divided by 28 minus 2 is 26 factorial. By the way, do you guys want to know how we did this in the old days before calculators?
Yeah. You just multiply each one a bunch of times.
Yeah. So here's my division. We had to do like 28 times 27 times 26. It's all the way down to 1. But it's not as bad as you think. Then we would have to do 26 times 25 times 24, all the way down to 1. But if you think about it, yeah, these cancel out. It's multiplication, remember? So all we had to do is multiply 28 times 27. So it wasn't that bad. In fact, it's almost easier than pushing all these keys in your calculator. 28, math, probability, number 4, divided by 26, math, probability, number 4, enter. 756. Okay, number 10. How many different 10-letter arrangements are possible using the letters in the word automobile? Now, how many letters do we have? What's my N? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be 10 factorial, right? Those are the number of ways. It's just a simple counting principle, except for one thing. Okay. I have 2 O's. So what am I going to have to do here? Divide by 2 factorial. So I have 10 factorial. Math, probability, number 4, divided by 2, math, probability, number 4, enter, 1814400. Almost 2 million.
Wait, where do you go again to do that symbol thing? So I can write it down so I don't forget. It was math.
Oh, the factorial.
Yeah.
So I put in the number, like 10 factorial, 10, hit the math key, go over to probability, and then you could either go down to number 4 or hit the number 4. All right, number 11. See, how many letters do I have in disappear? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 factorial ways of doing this. However, I have double letters in this one too, don't I? I have the P's. Not only do I have the P's, so I'm going to have to divide it by 2 factorial. Not only do I have the P's, but I have A's, right? So I'm going to have to do 2 factorial times 2 factorial. Now, a lot of students went ahead and did this computation before I could explain to them. 2 factorial times 2 factorial is not 4 factorial. Okay?
Don't you have to do the factorial?
You have to do the factorials first. So 2 factorial is 2 times 1, which is 2, times 2 factorial is 2. So this is 9 factorial divided by 4. Or just put it in your calculator and let the calculator do the work so you don't make that mistake. So I have 9 factorial divided by, now you're going to have to put parentheses around the 2 factorial times 2 factorial. 2 factorial times 2 factorial. And you should get 9720. Or you can just take 9 factorial and divide it by 4 and get 90, same result. Okay? And we're going to stop here. Okay, now we didn't do combinations. So on your homework sheet, bless you. You can do P, this number 2, number 3, number 5, number 8, 10, and 11. The other ones are combinations. So 2, 3, 5, 8, 10, and 11. 6 whole problems. Questions, comments, concerns?